Lesson 4: Nature-based solutions for roofs. In this lesson, we begin to go through various types of nature-based solutions. We start with the solution for the buildings in order to promote a sustainable and climate-efficient construction. Enhancing lessons learned by the implementation of LIFE-myBUILDINGisGREEN project, we will go through the set of NBS to improve climate comfort in buildings. At first, we will address the solutions for roofs, namely green roofs. In this brief session, we will go through the different types of green roofs and identify the main benefits for the use of green roofs in buildings, as well as the improvement of the interior climate comfort. At the end of these video lessons, we hope that everyone will be able to recognize the main functions of the roofs and their importance for the regulation of the indoor environment, distinguish the several types of green roofs, and identify the main advantages and benefits of nature-based solutions for rooftops. The history of the roof goes along with the history of man and its evolution. From an early age, men realized the need to protect himself from climate, natural disasters and dangers, as well as to shelter from the cold and heat. The man began by sheltering in caves or small cavities in stones or escarpments, and later was able to build his own refuges, starting with simple huts with branches and leaves, using natural resources he had at his disposal. In the search for shelter and protection, and bailing out the existing natural resources, man was able to innovate and began to put living vegetation on the roofs as a way to soften the interior temperature. The placement of landscaped structures on the roofs dates back to the earliest records of the ancient civilizations that populated the Tigris and Euphrates rivers, with the famous hanging gardens of Babylon in the 7th and 8th centuries before Christ. The warm and dry climate characteristics of these regions contributed to the appearance of these innovative solutions. However, later, the Romans also sought to implement this concept in their buildings, mostly associated with hot and dry climates, with vegetation contributing to shelter from the intense sun and soften the indoor temperature. With the discovery and development of materials, man was able to complex the construction process, giving rise to increasingly elaborate roofing models in materials and forms, opting mostly for sloped solutions in order to avoid water infiltration and accumulation of debris on the surface. We often see sloping roofs around the world, given the ease of water flow, offering itself as a practical and simple solution, and without great maintenance requirements. More recently, and with the development of lighter and longer-lasting construction materials, it was possible to resume the option for flat roofs, enabling the use of the roofing area for other purposes. The roof began to have a function in addition to protection and safety, and began to have a useful area and can receive and accommodate a set of equipment and service infrastructures, essential for the quality of life that is intended. However, the constant demands for comfort led to an overuse of heating and cooling systems with high energy consumption while devaluing an important available area, the flat roof. The scarcity of available space in cities has led to the development of solutions for efficient use of the rooftops, enhancing a more profitable use for the users without neglecting the essential function of the roof. Thus, as essential functions of the roof, We have waterproofing, thermal insulation, sound insulation, protection from climate impacts, and the safety of people and goods, among others. But we can certainly identify these as the main requirements that we expected a cover to have, whatever the material, shape, or layout. But it turns out we have seen a growing number of green roofs a little everywhere, with different degrees of inclination, with different volumes of vegetation, with various shapes and different uses. Undoubtedly, for this democratization of green roofs contributed some factors. The densification of flat roofs or low-sloped roofs enhances the fixation of the substrate to the cover slab, allowing plant species to grow and develop. The demand for greater energy efficiency. As we will see below, there is a greater demand for energy efficiency of the buildings by looking for more effective, long-lasting and low-cost thermal insulation systems. The green cover theft of these multiple layers contributed to a greater thermal protection of the building materials, ensuring a lower thermal amplitude inside the building, and thus ensure more constant temperatures with low losses. A greater demand for more sustainable materials and resources. Currently, there is a greater concern with the sustainable use of materials and resources, and with its ecological footprint. We are witnessing the emergence of innovative materials that incorporate recycled or used materials. The need to adapt to climate change and the increased risk of extreme weather events puts additional pressure on the roof, particularly in the level of insulation and waterproofing, forcing them to deal with ever-increasing thermal amplitudes as well as abnormal rainfall loads. All this has contributed to increased interest and bet on solutions for green roofs. Among the types of green roofs, we can be distinguished between the extensive and intensive, and there is an intermediate solution called semi-intensive, as you can see below. But it turns out that it is common to classify only between extensive and intensive, inserting the semi-intensive ones in one of these typologies. The extensive green roofs are characterized by presenting layers of substrate with little height and by the use of small vegetation. They are usually less demanding in terms of maintenance and present low variety of species. On the other hand, intensive green roofs present themselves as true hanging gardens, with a great diversity of species with different sizes. They have considerable substrate heights, capable of accommodating shrubs and trees, and are suitable for spaces for frequent use. The semi-intensive ones are included among these typologies, presenting characteristics typically of both typologies. In structural terms, the green roofs are organized by layers, with distinct functions and with a greater complexity in relation to the natural soil. The green roofs have the following layers on the cover slab. Waterproofing layer. This new layer on the slab improves and strengthens the impermeability of the structure, since it will have to deal with the accumulation of water in the substrate, making the environments on the slab wetter. This layer allows to keep the slab free of moisture of any type of infiltration. Anti-root layer. The existence of vegetation will create a network of roots that may break through the waterproofing layer and damage the cover, compromising the viability of the structure. This roots-resistant layer protects the waterproofing layer as well as the slab below, avoiding any damage and keeping vegetation away from the cover. Drainage layer. This layer is composed of alveolar elements that ensure the flow of water, preventing it from accumulating in excess in the substrate and causing damage to the vegetation. Filter. On the drain layer is placed a filter in order to allow the passage of water, retain the substrate and all sediments. These layers serve as the basis for the substrate, covering an entire infrastructure essential for the correct installation of a green cover. Substrate. On the filter is finally placed the substrate that will support the vegetation. This layer may consist of a mixture of different materials to ensure the correct circulation of air and water in the substrate. Vegetation. Finally, the vegetation that will create the landscape and provide the desired benefits is placed above. Green roofs can also present drainage or water retention systems with different compositions and heights according to the expected amounts of water. For wetter climates, it will be necessary to install systems with a higher porosity to accommodate higher amounts of rain. However, drainage can be ensured by draining plates or using porous or granular materials, such as small stones or goths. Blankets are used for extensive green roofs and for dry climates. The choice of the green roof typology that should be installed must take into account not only the load capacity of the coverage, but also the service of the ecosystem we want to see implemented. Green roof crops provide more benefits and services of ecosystems, depending on the greater diversity and complexity of vegetation, which is usually dependent on the height of the substrate. In this sense, roofs with higher load capacity can accommodate higher substrate heights and consequently receive a greater diversity of vegetation. However, when opting for a green roof should weigh many factors, including the viability of the structure, the drainage, the climate characteristics, because all options have various environmental, social, and economic benefits that will benefit the building and the users in many ways. Among the many benefits that green roofs presents, we can highlight: contribute to increase the energy efficiency of buildings by improving thermal insulation and thereby promoting the reduction of energy costs. Improves thermal insulation and increases coverage durability by reducing the thermal action of the sun's rays on the cover by about 90%, protected under the vegetation layer. Contributes to reduce the heat island effect due to the presence of vegetation that creates a cooler and wetter environment due to evapotranspiration. Increases the soundproofing of the building due to the multiple layers that make up the green roof. Improves the urban landscape by coloring the roofs and filling the surface with life. They also contribute to increase photosynthetic activity and thus contribute to oxygen production while promoting carbon sequestration, thereby reducing emissions of greenhouse gases. Promote increased biodiversity by promoting habitats and providing food and shelter to various pollinators. Contribute to the increase in green and permeable area of cities. Improve air quality by absorbing and filtering air pollutants. Also reduce the risk of fire through floristic compositions, roofs including greasy plants, slow fire spread. Contribute to reduce costs of maintaining buildings by increasing the durability of the roof and protecting it from the action of atmospheric conditions. Increase the useful area of the building, creating areas that can be used. Contribute to the integrity and sustainability of urban drainage system through water retention in the substrate. Green roofs are a value solution for buildings, regardless their use or function. The municipality of Porto is committed to the use of green roofs in municipal buildings. An example of this is the intermodal terminal of Campanha, a structure with 4 hectares of green roofs, which allows the creation of public green spaces while promoting the efficiency of infrastructure and increasing the durability of the roofs. For more information related to nature-based solutions for roofs or to the project My Building is Green, do not hesitate to contact us. Thank you.
In collaboration with the LIFE program of the European Union.